As previously pointed out, today is going to be a time of two types of problems involving rates of function, rates of reaction, or rate law. The first one is N2H4 plus O2 goes to form just atomic nitrogen gas and water. Now, the way you do all these problems basically is you add up the energy produced and lost to form the components in a series of smaller reactions. Now, if you'll note, I go through up here and say hydrogen plus oxygen forms water, and it's a negative 286 kilojoules per mole. Obviously, if you burn hydrogen and oxygen, it's going to produce a lot of heat, and it's 286,000 joules per 18 grams. Pretty large amount of energy. Now, some of these others, I get treacherous with you to make you think a little bit, and I'll give you the value in kilojoules per mole, and you'll have to figure out how much to multiply it to reach the proper amount. Now I back up a little bit because I give you the correct final answer. So let you, since I'm giving you most of this stuff already worked out, let you think a little bit along the way. Now the second derivation formula is diatomic nitrogen plus water forms N2O and hydrogen gas. And that one's listed as 317 kilojoules per mole. The next one is ammonia plus N2O. Goes to form nitrogen gas plus water, and the value of that is a negative 1010 kilojoules. So obviously ammonia and N2O, did I say water? It's not water, it's N2O. So ammonia doesn't react with water very nicely, produces a very large amount of energy. It's a very exothermic reaction. Then the last component reaction is N2H3, N2H4 plus oxygen forms diatomic nitrogen and water. And this one I cheat and give you the total amount, so you and then to get it per individual mole, we divide through the whole thing by 4. And it comes up to N2H4 plus O2, which is where we started, forms diatomic nitrogen plus 2 waters, and the total energy emitted is 622,000 joules per molecular weight per mole. Now that's the easy one. Now you say, well, wait a minute, that seems awfully hard. It's not actually, because oftentimes you'll be given the sub-formulas, and you'll just have to complete the formula and balance the equation. And then you can look up all the values. There's a chart that has all the values for the different components. So this is kind of piecing it together and getting a final result. So it's not extraordinarily difficult, even though it may seem like it to you. I don't know what's wrong with my camera today. For some reason. It must be the lights outside. And it happens, unfortunately. Okay, now the next point is that in rate law, the concentration of the ions in an aqueous solution and the partial pressure of gases at the same level are the same. In other words, they don't have to have a translator or equivalence um, to find similar values. They're accepted as fairly equivalent at equilibrium. So this is a hard one. You got the bromate ion, BrO3, -1, aqueous, plus 5 bromine ions, Br, -1, plus 6 hydrogen. These are all aqueous. Right? Means every time you say aqueous, it's dissolved in water. And it goes to form 3 bromine liquid diatomic plus 3 waters. Now the rate law for this operation is K is equal to bromate ion N, the bromine ion M, and the hydrogen ion P. Now the way you do these is you relate each individual one to its partner. Since there's 3 components, you're going to have 3 competing rate law relationships, and then add them up, and that'll be your final component. So we take rate 2 over rate 1, which is straight up, and the values are you'll be either given them or you'll have a chart in the book where you can look them up. None of this stuff is rocket science. It's complicated in that you have to, with some of the ones that I gave you earlier, you actually have to look at a graph and go to the X and Y axis to find the values, which makes it a little harder. But it's nothing that's beyond your scope of intellect. You can do it. It's just tedious. So I try to avoid the tediousness here by giving you all the values. Again, R2 over R1 is 160 times 10 to the minus third moles per liter second, which is again the units for value for rate law, divided by rate 1, which is 8.00 times 10 to the minus fourth moles per liter second. And the K value for the 3 components, listed in the reaction side of the reaction, is 0.2 moles per liter for rate 2, 0.1, and you divide through and you come out with 0.2 over 0.1, or 2.0 to the N. That's your first. Remember, you're going to do these to find the N, M, and P. So now we're going to go to P. We found N, and we're going to M, which is R3 over R2. Or 3.2 times 10 to the minus third moles per liter second divided by 1.6 times 10 to the minus third moles per liter second equals K. And K is 0.2 moles per liter to the N over K, 0.2 moles per liter to the N. 0.2 moles per liter to the M, 0.2 times 10 to the, see, that incorrectly. No, I did not. Okay. Moles per liter, and it comes out to 2.0 over 1.0, which is equal to 2.0 to the M. The last relationship is to P. If you can think of these, each one of these is valued in relation to N first, and then M. In other words, you compare the other 2 values, and then the last one is P. All right, so we have rate 4, 3.2 times 10 to the minus third meters, moles per liter second, divided by 8.00 times 10 to the minus fourth moles per liter second. Again, the values are 0.1 moles per liter to the N, and to the M is the bromine, N is the bromate, and then we're solving for P, and that means 2.0 to the P. Well, since hydrogen ion is the least of these by a factor of 2, we say it's second order. So it would be 2.0 quantity squared, and that P is second order. Or bromate plus bromine ion are first order, and second order is a hydrogen. So how does that matter? Rate is equal to K times the bromate ion times the bromine ion times the hydrogen ion. Remember, it is second order, so it's quantity squared. That's the one thing you always remember. The order determines the multiplying factor in this case. So we substitute for values. You got 8.0 times 10 to the minus 4 moles per liter second, which most of you figured out quite early, is equal to K times 0.1 moles per liter times 0.1 moles per liter times 0.1 moles per liter, which is what all of their concentrations is, or K is equal to 8.0 times 10 to the minus 4th moles per liter second divided by 1.0 times 10 to the minus 4th moles to the minus 4th over liters to the minus second per second. Now, the way that works out pretty straightforwardly is that the moles above reduce that and makes it moles per cubed. The liters cancel out, and the seconds, the liters multiply out. Liters times liters is liters cubed, and then they're all per second. And that's the way you do rate law relationships. Now, my suggestion is, and has been throughout all of this, that you have a textbook. Again, 10, 15, 20-year-old textbooks are the best, even 25 years. Someone who does a really detailed explanation. And what I give you here is a superficial explanation, and take it and try to grasp some understanding from it, and then go back and look at the section in the textbook. I also recommend Schaum's Outline in General Chemistry. It'll have a section on rate law. And when you go through this, the last two snippets that I've given you, and then go look at Schaum's Outline, you say, oh, okay, that makes sense. The idea is you hit this from a bunch of different angles to try to get the most comprehensive understanding. Because after all, this is a survey course. This is not a great in-depth course, but it'll give you a snippet of the topic. Now, a lot of the newer textbooks ignore a bunch of this stuff. They say, well, they can get it when they take physical chemistry, or when they take this, or they take that. I think that's unfair to you, because if you get a snippet and a decent superficial understanding, and later on when you get this stuff, you don't have to start from scratch. You've already had a minimal but fairly comprehensive understanding to build on, and it doesn't put you at such a distinct disadvantage. So that's it for rate law. I hope you got something out of it. Again, textbook, Schaum's Outline. Now, some of you may have wondered by now, what the heck does this benefit me? To take a survey course in general chemistry in a university is going to cost you $10,000. Now, if you're going to sink that kind of money in something, you want to succeed at it. If you'll go through what I have to offer, go get an old textbook and the Shams Outline, 15, $20, and an old textbook's $5 to $20, depends on where you can find it online or an old bookstore. If you go through this, you will have a one-up on everybody in the class when you go take the course. Now, most of you that have bothered with this to begin with are fairly serious students. You want to succeed at this. Now, the chances of success are directly related to the amount of exposure you have. So my little snippet course here, plus a little bit of work on your part with the textbook and the Shams Outline, will allow you to make that A that many of you want. A's in a survey course plus the general organic, plus many like to have you fairly proficient in physical chemistry, will allow you to get into these schools you want to get to. Pre-engineering, pre-farm, pre-med, those kinds of things. So this is just a helper to get you a better grade and a better understanding down the road. And again, I'm going to push on to other topics, but once you get to rate law, you've covered basically the first semester of the course, and most courses anyway. And if you can get a good understanding of everything that we've covered so far, you have an excellent chance to do well. So good luck to you.